you have heard of Flight? Raise your hand if you've... Okay, not a lot. That's not terribly surprising. They just really Twitter just debuted it at JSConf this year. So it's kind of a new framework. Just a word of warning, this might be a little controversial. I will try really hard not to name names, but I'm going to call out some frameworks on some interesting problems that I think are solved by Flight. If you have any problems with that, please feel free to find me after my talk or this evening, and I'll be glad to talk about it with you. Definitely an interesting topic. So we have a myriad of client-side frameworks today, and that's certainly not going to change. I'd never heard of Durandal before today, and I thought I knew most of the frameworks on the client side, which I guess was a bit of a fallacy. There's a brand new one every day, and it's purported to solve a new problem every time. But there's a couple of problems that I see prevalent with many client-side frameworks, and one of them is that they're monolithic. They're getting bigger and bigger, and they're getting harder and harder to break apart. When you download a framework, you download the entire framework, and you don't just take the bits and pieces that you want, you get the whole thing. And not only do you get that file size-wise and library-wise, but you get that in terms of prescriptiveness. The new buzzword is opinionated with frameworks. I actually despise that particular word because the chances of a framework author's opinions matching your or your team's opinions is practically nil. And so a lot of teams end up fighting these large frameworks that want to pick and choose every technology you use. They spend more time fighting them than getting the benefit of that framework. And I find that to be a major problem. Another problem with today's frameworks is they do want to JS all the things. I'm a JavaScript addict. You'd think I'd be for that, but actually, I'd really like to see HTML and CSS be leveraged for what they're good at, and JS be used for what it's good at. So Flight, it solves a lot of these problems. It has its own little caveats, which I'll get into in a little bit, but it solves a lot of these problems. It's absolutely tiny in terms of code base, in terms of size, and in terms of footprint. So it's 5K gzipped, and the thing I find amazing about it is it works with legacy systems. So if you have an existing Backbone app, an existing frameworkless app, an existing whatever application, it's really easy to integrate Flight into your workflow and slowly take over, or just keep it on as a side, as an addition. It's definitely not prescriptive, and the ways it is prescriptive have to do more with your architecture than your technology. And so I find the limited ways Flight is prescriptive to actually be a bonus as opposed to a hindrance. And then finally, it leverages HTML in the DOM. It uses native DOM events and actually lets you use the technologies for what they're good for as opposed to trying to put JS on top of everything. Like I said, 5K gzipped, very, very small. It does require jQuery, and jQuery is quite large. However, I don't find that to be a very bold assumption. Go ahead and raise your hand if you either work for a site or have written a site that requires jQuery. Yeah, a lot of hands. So not a bold assumption to require jQuery and then just put this 5K on top of it. It does use require or a require loader, Almond.js, remarkably tiny, and it doesn't tell you which require loader to use, so you can use whichever you like. So like I said, the prescriptive part of Flight is around your architecture. It's around constructing small modular components and building an ecosystem out of those components rather than prescribing, oh, well, you need to use this build process, or you need to use this testing framework, or this require loader. And so it prescribes best practices for your JavaScript code rather than prescribing anything else. Components are based on, so you write a JavaScript component and you attach it to a piece of HTML. That's pretty much it for Flight, and it responds and emits events. So you don't have to worry about the data binding layer. It's not already there for you, but you can write one. There's also several available because of the component structure. You can download someone else's data binding layer and just hot plug it into your application. And it uses DOM events, which most of us already know how to handle. We've already dealt with click events and long taps and double taps and whatever you want to talk about event-wise. You've probably already dealt with it, so you probably already know the event system and how it works with Flight. So the way components work is you set up your HTML for your component and your CSS and whatever else you want to do with it. You then attach a Flight component, which is basically a JavaScript object in a wrapper, to that HTML, and the component responds to and emits DOM-level events, and you go from there. So this is a diagram, basically. So you've got a button, and behind it is the HTML, and let's say the user clicks that button. That button will emit a click event. Now, these two, this could even be non-Flight code. I mean, that's part of why I made this diagram, is to show that Flight code looks so much like regular JavaScript, like regular everyday front-end JavaScript, that it's the same setup. So, and keep in mind, the button doesn't care who's listening or if anyone's listening to that click event, and both of those handlers don't care if it's a button or whatever it is that was clicked, as long as something was clicked. There we go. Of course. So components are defined fairly simply. You declare a function, you give it some defaults and an initialization method. You add some event handlers, and then you return that function wrapped in a Flight component call. This is your basic Flight module. So you've got your standard require.js syntax up here. You then declare your component function. This is the way you set up default attributes. An initialize function that's called after you attach your code to an HTML node, and then you just return the component which was required up here. So when you attach your component to a piece of HTML, it's just one line, and it attaches it to all the HTML nodes that match that particular selector. So if you use a class and there's 20 of that class, you'll get 20 of those. Something you should note from the attach to is it does not return anything. This is one of the prescriptive things I was talking about. Flight does not return an instance of a component, nor does it allow you to obtain an instance of any component. That once that component is attached to the DOM, it's on its own. The only thing it can do is respond to events and emit events. You can't mess with that particular instance of a component. So Flight makes these things, it takes all of these small attributes and makes it into a fantastic framework by making a modular code structure. You have a component, it doesn't care about how many of it are on the page, what's around it, what its parent is, what its children are, it doesn't care. It's that one particular component, and all it does is respond to a specific set of events with its own specific set of events. It's very API-based when you think about it, and it's extraordinarily modular, and this lends us some huge benefits. So as for the Mixins, that's another fantastic part of Flight. Class systems in JavaScript is an argument that has gone on for days and days and weeks and months and years, and will continue to do so. I find most front-end apps do not need a classic class system. And I've gotten yelled at for that before, and I will again, and that's okay, because I think the functional mix-in system is perfectly suited for 90 to 95% of front-end applications. So the way the mix-in system works, it's a lot like Sass and CSS mix-in, or it's not CSS, but Sass and Less and Stylus, whatever you want to, whatever preprocessor flavor you like, that mix-in, it's the very same concept, except with JavaScript. And so declaring a mixin is ridiculously easy. You just declare a JavaScript object with your shared functionality. And then when you call your component call, like we showed in the component, you will put your main function, comma, whatever mixins you want to add into that object. So this is like the definition of a mixin. It looks a lot like a component. The only difference is there's no component call at the end. You just return your function. Mixins are different from classes. Where I work, we're kind of still getting over that bridge of calling them classes and superclasses and subclasses, because that's really confusing when you're talking about mixins, because you talk about having multiple subclasses and it just gets really obscure really quickly. So definitely try to keep the vocabulary separate on these two. And like I said, when you do a mixin, the difference between that and what would be a classical system is the mixin doesn't override the class itself. So much like a SAS mixin where you call the mixin and then you do all the things that make your specific class or CSS class different from the mixin itself. It's the same with flights mixins. You call those, they do not override the including component. So overall, what this means for you, your team, your project, whatever you're thinking of doing, it's remarkably easy to integrate flight into an existing system, and that's one of the largest arguments for switching to a new framework. We can't take the whole application and rewrite it within a couple days, weeks, however long you think it would take to rewrite the application. Instead, with an easy integration system like flights, you can just slowly sort of go component by component and rewrite the site while interacting seamlessly with your older JavaScript code. The architecture prescription that Flight provides creates very scalable code, and not just code, but very scalable teams and very scalable code, like very scalable framework itself. So when you have these components that are completely independent and rely solely on APIs, you can have several developers working on different components at the same time without worrying about interoperability, as long as you can agree on those APIs and those exchanges. So one thing we've noticed is we were able to split our work into much smaller atomic pieces by saying, okay, you're going to go work on this component and you're going to go work on this one, and just make sure you agree on an API before you set out to do what you do. So it definitely made the team more, it made our work time more scalable by separating it out. It also made it's a very low barrier of entry to start with Flight. Like I said, it looks just like regular frameworkless JavaScript code for the most part. So because we have a low barrier of entry, when we bring in a new developer, it doesn't take weeks, it takes days, maybe. And that's because we have this huge Vagrant setup, not because of Flight itself. So you create a low barrier of entry, you can add more people to your project rather quickly, as opposed to them having to read your entire code base to get scaled in. You can get them started working on a component without knowing what the rest of the code base looks like. If you tell them, I want this component to respond to this by doing this, they don't need to know the rest of your code base. They can start working on that immediately. The final thought on what makes Flight great, it's super testable because, again, it's because of that API-driven structure of the components, because you know that this component is going to respond to this event in this way and emit this other event. You can test it really easily. So this plan's really difficult, and I know it's terrifying looking, but bear with me. The steps to integrate a Flight component with an existing JS architecture is setting up event handlers and event emitters in your old code. That's it. That's all you've got to do. And I know, terrifying, but that's it. I've kind of astonished myself, like writing my first Flight component in a rather large we had 3 different frameworks going on at once, so it was kind of crazy. We added in a Flight component, and all I had to do was go into one other JS file, emit an event, and I was done. I had integrated Flight into our existing system seamlessly. So definitely an interesting, good point for that. Again, with the natural scalability, because a good point about most frameworks, and I think there was a little bit of discussion about this, you have to let the framework do its job in order to get the benefits of said framework. So this is included with Flight. If you don't fight the component system, you will have a scalable code base. It will work. It's interesting to watch, and I suggest you all try it. Because if you just let the framework do its job and you follow the component system and you put your reusable code into Mixins and you just do these few steps that Flight's put out in front of you, you'll end up with this scalable code base. And then finally, with the testable code, like I said, if you've got a component and you know it will react to this event in this way and emit this other event, it's really easy to just set up a spy, attach your component, run it, and spy for that event. And then you've created a piece of testable front-end code, which I'm convinced is similar to a unicorn, because I've yet to find a regular piece of front-end testable code, at least in a production system. I've written a bunch in my spare time because, you know, they're tiny and they don't rely on anything. But you go into a workplace and try to find a piece of front-end testable code, it's a little bit difficult. So some general purpose things about Flight. Bower is required with big old quotes. I'm actually not a fan of Bower. I'm a Node user, and I'm a fan of using NPM for what NPM was made for, and that's modules, but that's beside the point. If you don't want to use Bower on a regular basis, you just install Bower, install Flight, copy Flight out of your Bower install directory, and copy it into wherever. The only thing you don't get is the updates that way, but you can just repeat the process. Definitely, there are some very good testing scaffolding libraries written for Flight already. I thought it was rather testable to begin with, but it's really nice to see that they didn't just write the scaffolding, they wrote it in 2 different flavors. So at the very least, I think most developers who do front-end testing are covered by Mocha and Jasmine. If not, it's remarkably easy to test Flight code, so it's remarkably easy to just build it out of whatever flavor of testing framework you use. Definitely check out the internal APIs, such as Advice, which is how they were doing the dot after initialize call. And you can actually take these internal APIs and use them elsewhere. They're AMD modules. You can just require them in wherever you need. And write about what you find. Like I noticed at the beginning, there's not a lot of people who know about Flight. Probably even fewer have used it. So if you take the time and write something in Flight, post about it, write about it, share your experience, speak at a conference. So definitely do something with the knowledge that you gain if you try to use Flight. So yeah, any questions? The question was, do we see a hit in performance with all the events flying around? With today's modern browsers, even with IE8, no. There simply aren't enough events to cause a queue that would cause a perceptible decrease in performance. You'd have to have thousands of events firing per second in order to see a bog down in even older browsers. So no, we have not seen a performance because of the event system. On mobile, actually, it's worked great on mobile. Same thing. You'd still need at least, even in the worst case scenario, you need hundreds of events going on each second and animations going. I mean, if you have an animation going, it's going to slow down the rest of your JS code, but the event system itself would not. Browsers are actually optimized to handle event systems, and that's one of the reasons using DOM events was such a great idea, is browsers know how to handle DOM events. They've been doing it for years, and they've been optimizing for it, so why not take advantage of that? The same way jQuery and the DOM handle it. So everything bubbles up. You can cancel propagation. You can cancel bubbling. You can return false. You can do all the standard things you would do with regular events.
From the example of class names, you could say attach that to like a container and listen for it there. So if you added a new one.
The question, sorry, I forgot. It was how it handles event delegation, and the follow-up was we can attach a class to a container, and it would watch for new objects or new events. Yes, everything you can do with standard JavaScript and if you use jQuery, the jQuery.on handler, you can do with Flight. So the question is, coming from a traditional MVC background, how do you handle models? There's no set way to do that. You would build your own model, either mix-in or component, and you would go from there, basically. So one of the people who wrote Flight, Dan Rong, was quoted as saying that Flight isn't so much a framework as it is a framework for building your framework. Because it's so unopinionated and so it only worries about your architecture, you can build how you need to build for your application and go from there. The question is, can you use Flight on top of any other JavaScript MVC framework? Yes, you can use it on top of anything that allows event handling and anything that allows anything that doesn't muck with standard event delegation. All right. Well, thank you very much.